Welcome to Ask and Learn.
Hi everybody, thanks for joining me today. We're going to be looking at a problem that explores the relationship between kinetic energy and work. So what we're given is we have a car that is moving uncontrollably at a speed of 65 miles an hour towards an array of steel barrels, A, B, and C, and each set of barrels provides a different amount of force over a different distance. So the barrels at A provide 18 kips from 0 to 5 feet. The barrels at B provide 27 kips from 5 to 14 feet. And the barrels at C provide 36 kips from 14 to an undetermined length. What we're asked to solve for and what we're given is the mass of the car is 2,250 pounds. The velocity of the car is 65 miles an hour. And we're asked to find what is the total stopping distance and what is the maximum acceleration of the car during its period of hitting those barrels. So the first thing that we're going to do is we're going to actually assume that the car stops at less than 14 feet. So we're only going to be using the forces from the 18 kips and the 27 kips. And we're just going to use the equation that relates kinetic energy to work. And we know that kinetic energy at the beginning is simply 1/2 mv squared. Kinetic energy at the end, since the vehicle is being brought to rest, is 0. And the work is simply going to be those forces that I mentioned above acting over the prescribed distances. So we assume that the car will be stopping at less than 14 feet. So we know that the first set of the work done is due to the 18 kip force that's acting from 0 to 5 feet. So that's going to be 18, I'm just going to cite that as FA times XA. And then we're going to have the 27 kip force acting over an undetermined distance. So that's going to be FB times X. Remember, X is what we're trying to solve for. So we can set these equations, set this expression and this expression equal to each other. And what we end up with is 1/2 mv squared equals FA XA plus FBX. Now, if we solve for x, what we get is that x is equal to 1/2 mv squared minus FA XA all over FB. Now recall that we actually know all of these, the value of all of these variables on the right. We know that the mass is 2,250 pounds. We know the V is 65 miles an hour. We know FA is 18,000 kips, XA is 5 feet, and FB is 27,000 kips. So what this gives us is an X of 8.427 feet. Now this is not our total stopping distance. This is the distance traveled in the 27 kip zone. So the reason why the 14-foot assumption is valid is because we see that 14 minus 5 is 9 feet. And that length is what the 27,000 kip force acts over. So we see that this 8.427 is less than 9 feet, which means that the car stops in that distance. So by taking this distance, the 8.427 feet, and adding it to the 5 feet originally from the 18,000 kips, we get a total X stopping distance of 13.43 feet. And that is our final answer for this part of the question. Moving forward, we're also asked to find the maximum acceleration. Now, looking at Newton's second law, that F equals ma, you can see that to get the maximum acceleration, we need to maximize the force because the mass is going to be the same of the car. What we have is that A max will be equal to F max over m. Now, if we go back up to our problem statement, we see that the maximum force the car undergoes is this 27 kips. So by using that value, what we can do is we can solve for the maximum acceleration. So by plugging this in, so we get 27,000 kips, which is going to be, or 27,000 pounds, which is 27 kips, divided by the mass, which is going to be 2250 pounds over gravity, 32.2, which will give us a maximum acceleration of 12 Gs. And that is our final answer.